and then so it means current in the current is across the capacitor. So if current is across the capacitor, so that means L1 equal to L2 plus LC1. Yeah. So, and we know that in a circuit, regardless the element in the circuit, if since the voltage is across the element, it's always the current times the element. Yeah. So we can make current in the capacitor the subject. So we can say CI1 equal to L1 minus L2, and we know our IC1 is C1 dV over dt equal to 1 over C1 L1 minus 1 over C1 L2. So we can call this our equation 2. So let's move on to the next step. So we're moving on to the next step. The next step, we are done with loop with node 1, this node. So we are done with this. So we are moving to the second node. So we can also say since we are applying KVL to node 1, we apply KVL to node 2. So we apply KVL to node 2. Okay, so apply KVL to node 2, and which says the same way. So in node 2, we can say the current going in, but the current going in, it's going across the capacitor 1. So we are saying minus VC1 plus L2 which is differentiated into DI-L2 all over time, the differential of time, plus a voltage across capacitor 2 equal to 0. So we can make this here the subject. So we can say L2 DI-L2. We are only using I here, this I here, because it's a current. It's a current going across, because like I was saying, voltage going across an element, regardless the element is a resistance, a capacitor, an inductor, whatever, or whatever it should be. It is always, like, for example, the current going across a resistor is IR. So the current going across, the voltage going across a resistor is IR. So the voltage going across an inductor will be IL. So that is why we have this I here. Yeah, I'm just trying to let you understand the basic. So we can say DI-L2 over dt equal to VC1 minus VC2. The voltage across the capacitor, and the voltage across capacitor 1, the voltage across capacitor 2. But we know capacitor 1 equal to 1 over L2 VC1, and then yeah, we can say no. Yeah, in this case, the only thing we have to do here is we have to divide here by L2. So we have 2 dt equal to 1 over L2 VC1 minus L over V2 VC2. So we can call this equation 3. Yeah, we can call this equation 3 here. And then let's move to the next step. We know L currents moving in the capacitor LC2 equal to C2 dV C2 over dt. And then we can say this here divided by c2 so dv c2 over dt equal to 1 equal to this. So we can see this. So we can say since there are 4, so ever since we started calculating in the circuit, we had 4 different kind of let's say order. So since there are 4, so since there are 4 charge storing elements, then we say the order of the circuit is 4. Yeah. So since there are 4 charge storing elements, then we say the order of the circuit is 4. Yeah. So that's all for the second question. So we are going to the first question now. Okay. So here we go again. Sorry. So we are going to question 1. And question 1 says, sorry for the checkup. Let me check up here. Okay. So question 1 says, okay. Question 1 says, GS equal to K over S plus 3 S plus 5. And then question 1 is asking you to find the breakaway points, the asymptotes angles, the intersect of asymptotes of root locus. And then they're asking you to determine the points where the root loci cross the imaginary axis.